Do you mean in general or just for recording the meeting?
Yeah, so recording is fine.
Alex, are you okay? Right. Well, I'm ready to go whenever everybody is.
I think start is a good idea.
Yeah.
It's get my screencasting. Should begin. My Teams is in don't disturb me mode. Can everybody see the screen?
Yes.
Yep.
Lovely. Does everybody know who we are? Because that was an interesting. This has probably got a bit of bump at the beginning, but if everyone knows who we already are as an organisation, I won't cover too much of it. But I wrote this to be generous in case we had a larger audience, people who didn't know who we are. So if at any point everyone feels like they already know this, do kind of put the team's hand up and tell me. But yeah,
As we're recording this, it might be a good idea just to give a very quick overview.
Okay. So good morning, everyone. My name's Lewis Dean. I'm one of the founders of VISR. We are a member of the IoT. We're a Microsoft Mixed Reality partner. We've been operating for about 7 or 8 years now in the northeast of England, and we're an established spatial computing business. So we build spatial computing services for industry, and we also have a deep and kind of entrenched passion for enabling new learners to come into the field and understand what it is and what we do. And it's a little bit of a black art, spatial computing. It's sort of one of those verticals of technology that's in everything and is going to be in everything in the future, but it's not really discussed. And, a bit like VISR, we've been around for a very long time and we work with, some of the biggest organizations in the world on their spatial computing vision. We help organizations like Unity and Microsoft and Vodafone and Centrica. We work with Centrica locally, which is quite interesting. We've got quite a big energy portfolio that we work with, and the MOD and Wessex Water, et cetera, deal with this problem. And the problem is the spatial computing problem that nobody knows exists until you tell everyone, and then they go, this seems like a really important thing that everybody probably should be thinking about. And so, to give us a bit of underlying, we're a mature business. We've worked for a very long time in this industry. And our kind of offer to the IoT was, hey, we understand this field. We understand how important this field is to the future of industry and therefore to the future of training and vocational training and information training, and how educators produce the kind of candidates who are going to be able to work in this field, in these industries, because this industry touches almost every vocational field in the world and has enormous reach into the workforce, both from a information production perspective, so people who were training to produce and design experiences for spatial computing, but also for the kind of people who would consume those experiences, people who work in frontline work. And so to sort of summarize on what the idea is, that skips that slide automatically, apparently. It's gone haywire. Why is it playing my slides automatically? I have a load of timing advances on all these slides. Hang on. Sorry, everyone. That's better. So, sorry about that. To summarize, that kind of ruined my big introduction of this topic. To summarize, the idea of spatial computing is to turn real world problems into computer problems and apply computer logic to solving them. And what I mean by that is that we are teaching computers to intrinsically recognize and work with the real world that we live in on an information level, as opposed to trying to break it down into some, tabular computer form data. And this problem has been around for ages. This is not a new problem. This is like since the dawn of computers, people say, how do we take real world problems and make computer ones out of them? That's ultimately what programming is all about. But there's an interesting cultural angle happening here that's not really considered up until about 2 years ago. And this was driven by, computer technologies like AR and VR coming on the scenes, where there's a much stronger link between the real world and the computers than there had been in the past. So existing methods of modeling the real world for computers don't really work anymore. And it's good to kind of rewind this. So this is a really famous piece of information. It was actually put together by Steve Jobs, and it's kind of one of Steve Jobs' light bulb moments, but I really like it. And he said, information technologies allow us to exceed mental limits in the same way vehicles exceed our physical limits. So this is a study on the right of things that move on the Earth versus how many calories it costs to move them 1 kilometer. Calories per gram per kilometer, and along the bottom is the body weight in kilograms. And if you look at the chart in the left area, we are very inefficient. So we're like here. PC today. So if I kind of draw a line around, this is where man is fairly, we're sort of like middle of the field, about 2/3 of the way in terms of efficiency. We're beaten by horses, we're beaten by cows, we're beaten on efficiency massively by mice, lemmings, rats, fruit flies, bees, locusts, rabbits. Pretty much everything else on the Earth that moves around is much better at moving around than we are. Until you look to the right here. So on the right here of the graph is mechanized inventions that we've created. And sort of like winning statistically is man on bicycle. So man on bicycle is one of the most efficient ways to move around on the planet. And we've made that using technology. So we've created mechanized transportation, allowing us to absolutely exceed our biological limits. So we become the world's most efficient organism at moving around because we create technology to do so. And Steve Jobs said this interesting: a computer is like a bicycle for the mind. So a computer is a mechanism, an invented mechanism that we use to accelerate our ability to process and deal with information. We're still intrinsically part of a computer system when we use one, but we offload things that we're not organically adept at, like doing vast information calculation or being connected to hundreds of different sort of information points at once. And this is the sort of interesting problem that's posed, because in the global workforce, there are 1.2 billion people who work as what's called information workers. You can think of this group of people as the group of people who use the mind bicycle to do work. So they have mechanical information machines that help them process their kind of information. So they're usually people sat at desks or in front of computer terminals, or they use computers in a mobile form factor in their work. This has been really interestingly highlighted over the last 12 months because this workforce of 1.2 billion people were the least disrupted by the COVID pandemic, because they were able to uplift their information work in a mobile computer and take it home and do it at a desk at home. They were able to translate their information processing work from one geographical location to another because they're well served by the information portfolio that they're offered. So they have laptop computers and they have smartphones and they have all these interesting tools that we've developed over 30 or 40 years to work with information workers' workloads. And it makes really good sense because people who do information work are processing information, and computers are extremely good at processing information. So they're sort of like a match made in heaven as far as the way they work together. People have to instruct computers to move information. We're doing it right now. Most of us are sat, behind a desk disseminating information. We're actually, it turns out though, a lucky few. And this is the sort of underlying thing that I really like about spatial computing. So everyone thinks about people using technology at work. They almost always think of this picture: somebody sat at a desk using a nondescript, unbranded laptop, because this image is from a royalty-free image collection. But it's somebody sat using a PC at work. And there are billions of people in the world who work like this, and they generate massive value for the economy. But something else is going on behind the scenes, usually doing the sort of messier jobs. There are 2.4 billion people who work in the global workforce as frontline workers, and they don't work with information in their day-to-day jobs. They work in services or task-oriented roles across varieties of industries like retail, hospitality, manufacturing, and they drive the bottom line for organizations, define their customer experiences. So this is the person who serves you coffee in the morning, this is the person who comes to fix your boiler. And they are usually the face of whole organizations. So organizations, often think very much about the portfolios they offer their information workers, but they don't think about the portfolio that's offered to frontline workers. And if you think about it, these deskless people who don't work with information in their everyday jobs don't have access to technological empowerment in the same way that information workers do. They don't have the mind bicycle. They don't have computers specifically designed for the kind of work that they do. These people are not technologically enabled in their work. And that sounds like an obvious conclusion. And obviously someone should just give them a computer so they can have some information, but actually that's not happening. These people are not being, you can't take a laptop and give it to somebody whose job it is to repair boilers, because the laptop form factor is not compatible with the way that they work, and the information that they process and deal with when they're repairing a boiler is often not something that you can capture in a spreadsheet. It's information about how the boiler's plumbed in, whether or not the pipes look right, and whether it's too hot and when it was last turned on. And information like that is key to that kind of job, but we don't invent or build computers that deal with that kind of information. We build information processing machines because people at desks who build the computers, that's what they think it's for. And so while information workers and computers have natural synergy, we don't have natural synergy between frontline workers and computers. And it makes sense because computers are really good at understanding structured tabular data. Every piece of information that comes out of a computer is a piece of structured tabular data. And if it doesn't look like it's a piece of structured tabular data, then the computer is cleverly lying to you. So, typical things that people think of computer processing are like spreadsheets, time series, transactional data, banking information, statistics, piles of numbers that go in a line. And then people go, oh, I can watch a video on my computer and that shows me an image of the real world in it. But actually what's really happening is your computer's very quickly showing you a series of numbers really fast on pixels on a screen, and your mind is tricked into thinking that the computer has some understanding of it. Computers are really terrible at understanding non-structured data. And the problem we have with this is that this is what the real world looks like. It's an unstructured, organic, messy set of data, and computers really struggle with it. As an interesting piece of data, here on the left is some lounge at Microsoft, and here on the right is how a computer sees it. And it's not a trick question that the one on the right just looks like a mess. And imagine trying to instruct a computer to define or divine some kind of structure out of that, and say, oh yeah, that's a chair, and that's this living room, so therefore I can work my way around it. So if your job is to reorganize living rooms based on client specifications, a typical frontline worker job, you would struggle to get a computer to help you with that job because the computer wouldn't know where to start. And so when we talk about spatial computing, the field, the idea here is to bring computers out of offices and into the real world by teaching them how to understand it, how to properly reason about the real world that we live in the same way that we do. So people whose jobs involve that form of reasoning can be empowered by technology. So they can work like this. And so that machines and the way that they work are an intrinsically connected pair, the same way they are with information workers. If we as information workers didn't have strong computing portfolios, strong connectivity portfolios, our jobs would have collapsed under the pandemic. And it's no surprise that the jobs most put at risk during the pandemic are these kind of frontline work jobs, where people have been unable to access locations, are struggling to process information because they were already underserved. And so the goal here is to empower frontline workers to work differently by building technology that gives them, for the first time, a comprehensive portfolio of work. And this is actually a huge hidden industry. So this is an industry that's being attacked by every single big tech company in the world. The startup scene, we're a scaled up startup business, but we're essentially still growing, is all over it. And more organizations who we're partnered with, like Microsoft and Centrica, we're doing a big digital transformation at Easington Gas Terminal. They understand the value of moving towards this kind of work. And it's sort of a light bulb moment for them to think, why have we never thought about this? Why have we still got people out in the field with a piece of paper which says on it where things are, and then they have to go out and look at labels on valves and try and figure out if those valves are the labels? Why do we work like this? Why have we surged ahead with smartphones and tablets and PCs in the office, but we've let all the people on the frontline work have horrible information processing capabilities for years? And it's more than just altruism, because ultimately the business then looks at the business impact statement and says, and this is costing me money. I'm paying people to waste their time because I'm not providing them the right kind of technology. And so we can change the way that work is done by using spatial computing. And one of the things that's important for me to get across to the educators, which is why we're really passionate about being part of YHIoT, is this is going to be an enormous underlying foundational field of information technology that will touch every aspect of vocational and non-vocational education, because everybody's going to have to be involved in this conversation as this revolution is happening. And it's already happening. It's been happening for 4 years now. So there's going to become, a bit like we're already trying to figure out how on earth we produce enough computer scientists. It's going to be worse when we do this, because this is going to involve every industry suddenly screaming for people who are capable of building, authoring, and working with these kind of experiences. And we underserve this market because it's new, because we don't really know it's there. And so, you know, we're building out technology as an organization to help kind of take this idea and scale it across business. But it's going to have a huge intrinsic need for people who understand how this kind of world works. And this is kind of one of the technology slides that we talk about. This is actually a map of easy to terminal when we've done the work. One of the things that we've done that's really innovative, we've done this with Microsoft, is we're taking this idea of like a VR volume. So everybody here's had to go VR. Presumably you're seeing somebody use it. You're done in your living room and you get the controllers out and you do some stuff. And maybe the volume that you're tracked in is 4 meters by 5 meters, a big lounge. Or you do it at uni and they've got a slightly bigger room. 9 meter by 6 meters, I think, is one of the larger ones we've got here. In this environment, you can start to build this VR training content. So it's interesting. You'll notice I'm not talking about AR or VR training content, because we understand the value of this. You know, you can build VR experiences which help you train on things that don't really exist. What's interesting is that the work that we've done with Microsoft, we want to take that capability and make that tracking volume 5 hectares wide. So an entire organization's physical place can be treated like a video game. And in that video game, a video game is the most perfect way to transact information between people who are doing some structured, organized task together, like a frontline workforce. So does anyone want to say which game this is?
Dota?
Yeah, it's Dota 2. And it's quite popular in our office. So I always use these analogies. I find it's really interesting, because we now come on to the point where do all the learners come into this? It's really good. We've got this future of technology where all the people who do manual work are going to have helmets on their head and they're going to be instructed by the computer what to do. We need to find people who understand how to speak this language and who are ready to be educated to be the next generation of people who produce these experiences for these frontline workers. That's the point of an Institute of Technology. We're looking at where technology needs to be applied to the future and how we should be training people to be the ones who produce this technology. This is really interesting because a lot of people have this sort of weird dichotomy, sort of like intersectional conversation where they'll say, I can't stop my kids playing Roblox or Dota or Minecraft, and I wish they'd get down and do something serious. And then you analyze what's actually happening when games like this are played. So here's a group of 7 people, and they're performing a highly coordinated, complex task that they've undergone training to perform as a group in an extremely efficient manner, where the efficiency of this task is measured by the game, and if they're not efficient enough, they lose. So the people who play these games and obsess over them, the younger generations who are growing up talking this kind of language, already understand how to produce, author, and what expectations they should have from this kind of content. Minecraft is about building 3D content, persisting 3D content collaboratively with other people. And we need to, as educators, make sure that we're harnessing the ability to transfer these skills into transactional relationships with future work. And that future work is not theoretical. So the work that's going to need to be done here is all the frontline worker training and task organization in the world is going to run like a video game in 15 to 20 years. That will happen. People like Microsoft and Google will spend too much money on that for not to happen. And you've seen, you know, headsets in AR and VR, it's AR on phones or AR on headsets. I've always been very agnostic. I don't care how it gets into the workplace, just as long as it has a camera on it and it can see where it's going. That change has an enormous impact on global GDP, which is really interesting. So this is a report done by PwC called Seeing is Believing. Turning the world into a video game and writing tutorials for the people who work in it is estimated to have a $46 billion GDP boost in the year 2019. And then it gets bigger and more insane as you do the data explorer. So I'm not going to sit and go through the spreadsheet with you, but this is on the PwC website. It's called the Seeing is Believing report, and it studies the impact of AR and VR on technology. And, you know, even in 2019, when they did this study, they found that this kind of technology was already impacting nearly a million jobs across the world. And although that sounds like a small, you know, it's 0.04% of the global workforce, it's growing. And, you know, with VR landing in a 13 billion increase in GDP, but more interestingly, AR having the lead in the field with 33 billion. AR is going to change the world of work universally. And we should be producing people who are ready to work as content producers, content authors, and also on the flip side of it, ensuring that the people that we train vocationally understand that they may be asked to use this technology and understand what it is. So, you know, when people are given a HoloLens to wear, they don't go, what the fuck is that? They actually have an understanding of how that technology is going to be applied to their work and have had some kind of experience. And we've sort of already been doing this, because for years we've been kind of preparing these like video game design courses. Every university's had a video game design course for a while. You know, I was drawn to Hull University because it had one before it was cool, which is always usually the sign that a university's onto something. But you know, for at least the last 10 years, that message has been spreading, and now there's a good kind of propagation of understanding inside of education that we need to be teaching people to build video games. But the kind of what's going to come over the crest of the wave like a great big ship in a minute is the realization that these skills are globally applicable to all industries. So while we've been getting excited about, oh, I get kids making video games make loads of money, and you know, it's good for the UK economy that we export video games, it's really good for the UK economy that we can have a strong and competent workforce that can work with spatial computing technology, because we can become a front runner in the global industry of change at work. And I have a really kind of key passion point of this, is that when we talk about technological enablement at work, you'll notice I'm not talking about getting rid of people. I'm talking about giving people computers and making them faster and more efficient. You know, that's a really positive role for machines that are typically seen as a threat to the world of work, particularly vocational work, has to play in this. A narrative that sits really well with people who work on oil and gas facilities, and you know, they're worried about their jobs and their future. So, well, you could reskill using this technology and move forward into green energy, or deal with your plant when it gets hydrogenified. So for me, the learners in this story are the ones who are going to become the wizards and the architects of the digital world of frontline work that's going to get built. For us, that was sort of the underlying concept behind why we wanted to join the IoT. And use the capital investment to build pretend versions of this in our office. So we put together a VISR hosted center. It was launched last year, so we opened it just in time to shut it down for an entire year and have nobody there. That was really good timing on our part. But you know, it's still there. We still have 2,000 square feet of building that's there for learners and full of this technology. So in this building, we have the capability to demonstrate to a class of learners or a class of teachers who want to learn to teach learners how this technology works from end to end in the world of work. And we've built out the kind of demonstration equipment where we've got little bits of industrial plant equipment. We've got little control room scenarios where you can run the end-to-end experience of how somebody would go about authoring this kind of content for the world of work, in the same way that we author it for people like BP and Centrica and other organizations of that ilk. And you know, the goal here was to be able to run learners through. Oh, that's a video that should be playing actually. The goal here was to be able to run learners through the full kind of portfolio of skills required to do this sort of digital content creation. And it was really important for us that, you know, for as long as we keep it open here, that the visiting of this center and setting up lessons and sessions around the technology and the equipment that we have here is free for IoT members. So any other members of our IoT, you should come to our office. You can bring a class of people to our office. We can take up to 30 when that's allowed. And we have all this stuff on show. So you can start to weave this narrative into your kind of learning syllabuses, or you can use it as experience days to, you know, broaden people's knowledge or understanding of where the skills that you're teaching them may go. Horrible audio on that. And you'd be surprised how this stuff's built. So a lot of these tools look like things that we're already using to teach them. You know, the VR and AR workflow designer looks like Scratch, if anyone teaches Scratch to FE and HE learners. And then the back end of it is written in Unity for people who are working in university setting and understand programming by this point. So we have loads of tools that people can use to interact with this future, and we have it all on display, ready for anybody to come and visit should they wish. There you go, here's one of the tools in action. And so for me, it's about this, you know, a frank conversation about we need to be ready as educators of people who are going to build technology in the future to inform them that this is how they're going to be doing it, and make sure that they are inspired by this, because it's an inspiring, wonderful future to work in, but more that they are also carrying the torch of this concept into the future, because ultimately they'll be the ones who make this work. This is a 15-year plan. You know, this is going to take 15 years before everybody works like this. this is the right time to start thinking about how we teach these people and who these people are going to be, who are the information commissioners, as we call them, who create the missions that are run in the real world by the people who do boiler service maintenance, or the people who work in an oil and gas facility, or hopefully by then a hydrogen or a wind facility, because they're all the same. You know, there's an exciting future coming that we're probably not quite ready for. But you know, we joined the IoT to hopefully lay some of the groundwork of being ready for this future, and tell people like yourselves about it, and hopefully get you excited about where the future is going to come from and what the job opportunities are going to be for learners in this field. And we look forward then to kind of taking the conversation forward. And that's sort of the end of my more structured part of the narrative. Hopefully it wasn't boring. It's just an interesting message that's that tickles the interest of a few people.
It wasn't
Yeah,
boring.
that's
It was
fantastic.
very useful.
Thanks, Lewis. That was really, really good. Really useful.
I'm glad somebody recorded it, because I have a habit of doing a presentation and forgetting everything I said, so I can look back through that and say what was I talking about.
So in terms of like students for the IoT, so what are the kind of key skills that that the students need for, you know, to get into this kind of work?
So some of it's already happening. So foundational computer science teaching at school and at college is leagues ahead of where it was when I was there. So we're beginning to teach students computer concepts in a way that they need to understand, and we need to make sure we carry on doing that. And I think actually there's already been a lot of good work done in that field, and is going forward. That's not really something that I think should change. I think the teaching of foundational programming concepts like Scratch and Raspberry Pi and microbit and things like that are really important, because they teach those sort of like base understandings. When we build tools for industry, we try very carefully to copy those kind of very early concept tools, because there's a high likelihood then that there's a spread of understanding amongst a particular demographic of a certain age, because they would have been taught tools like Scratch at school. Visual programming is a really key point, and visual programming will become more and more important to the way that, you know, not everyone's going to be a software engineer in this future. That's the really interesting bit. It's not going to all be, you know, wizards who can write the best C code in the world and could build a computer out of bread if you ask them to. It's going to be people who, you know, will sit in the middle, and they might be operation process managers who study process, and they study team management, but they'll be required to produce programs that will run on a workforce of people as opposed to running on computers. So this understanding of some elements of visual programming and the base concepts of computing should be as universal as teaching maths to people, because not everyone you teach maths to becomes a mathematician, but you do need maths to do a wide variety of jobs. So making sure that we do have those levels of foundational understanding of computer science for every learner is going to be the key to this taking off. But from that point forward, so we're talking kind of, you know, you're 14 to 16 and you've been taught about how to put together blocks on the computer. Anybody who diversifies into different fields should still be able to pick up and work with this kind of technology. We're working hard as the industrialists of the market, if you like, to make it easy. And it's supposed to be easy, and the best way of describing how easy it is people should have a go at how easy it is. I think, Amy, you've had a go. So, you know, that it's not something that's kept behind a glass box only for people who understand computers to touch. It needs to be more generally available. And that's the sort of, if I had a message for the IoT members, you'd be surprised which of your courses are applicable for bringing students here and getting excited about it. It's not just the computing courses. It could be people on the building courses. I think Maureen has a hand up.
Yeah, I think that's a really interesting point. You project, none of you know who I am, so I'll tell you who I am. I'm Maureen Vivers. I chair Askham Bryan College, but I'm a career-long IT person, and I've spent my whole life since 1974 trying really to do what you're talking about, trying to make the computer disappear and get back to the real world. And actually, what I've always found, and I'd be really interested in your comments, is that it's not that hard to get people who are capable of doing the technology, to teach people how to program, how to build amazing stuff. Not everyone can do it, but those who can do it, you can train them to do it really well. The hard bit is, it's the light bulb moment bits. It's how do you get that level of innovation in a company where, so at Ask and Brian, how do I get the lecturers to have these light bulb moments that say, I can see a brand new way of teaching my students? Yeah. How do I get the admin managers to think, I can see a really interesting way here of how we could run the college and how we could timetable it and how, you know, how our farms could be treated completely differently. And I've always found that the hardest bit. I've sat in that space trying to translate between the techies on one side saying, well, what do you want us to do? And the users on the other side saying, well, what can it do? And I think this is really hard. And I think I'm impressed by you setting up demonstration facilities, etc., because I think that's one of the ways of doing it. But I think there's a lot more to do to get people who are currently excited about video games to be equally excited about what's going on in commercial organisations, because it's not as exciting, and it needs to be as exciting. Sorry, I'll shut up. I get quite passionate about this.
Well, no, I mean, it's a really good point. And actually, from my point of view, that's one of the reasons we made a demonstrator, because it's sort of like, aside from quoting PwC, but like, you do actually have to see it to believe it. And when you wear the helmet, which is shining lasers in your eyes and creating virtual images of things that don't really exist, it doesn't matter what field you're in, it's cool and it's worth getting excited about. But I actually agree with you on that point. And one of the things that, so before I even went to Hull Union, before founding this company with Lindsay, I was a games tools engineer. That was my job. And my job was to talk to artists who don't give a monkeys about what the technology does. They want to look cool and I have my artistic vision, and that's all that matters. Get artists to use technical tools to build things for video games. And it was all about that narrative of making sure that there's the right cultural understanding amongst the artists, that the tools are there to enhance their art. And if you think about teaching, as an example, if you wanted to give a presentation 40 years ago, you'd have to commission a graphic design firm to make you a set of slides on slides that you'd put into a kaleidoscope projector, and it cost you a fortune, and you'd spend a week doing it, and then you'd have a set of slides you could use for presentation. So teachers wouldn't think about using graphic slides because they were a pain in the ass. So they would teach, they would write things on chalkboards or whiteboards, or they would create OHP film, they'd write on there, or they'd photocopy OHP film. And, you know, the techniques got more and more convoluted as they're trying to get more information up onto a projected screen. And now everybody uses PowerPoint. And PowerPoint is ultimately a technical tool designed to help the everyday person use technology to author presentations. Nobody would dream of doing it like that anymore. And that's the really interesting part, is that we stand on the cusp here of, yeah, it's not about the technology people, because VR is cool for me because I'm a mathematician and I like the idea of the mathematical problem of how I turn a room into an equation and teach it to a computer. But it's ultimately about the process manager who gets excited because, you know, 20% of the new hires break the boiler every time they maintain it. We did a field trial with a customer who's, you know, their new engineers came in, and 3 of them broke the generator, and 1 of them dropped a water pump in the bin and took a whole building's power station offline. And the engineering manager was going, oh, for God's sake. And then we showed them, we did another trial with the HoloLens on, and they all got it right the first time. And the conversation about the technology went away, and it's okay, yeah, I want to guarantee that that's going to work. And in the same way with you know, teaching, and, you know, we're working with Ask and Brian on something new and exciting, so I'm not going to spill all the beans on how that's going to go, but we want it to be as useful a tool as PowerPoint in the classroom, with everybody in every field able to tap into the capability it gives you. And we've thought a lot about, particularly the virtual environment teaching stuff that we're doing, being extremely accessible for everyone to create for and everybody to use as a tool for information transference and information capture, which is key, is really important.
So I've got my hand up, Lewis.
Oh yeah, sorry.
Yeah. So no, I was just going to pick up on Maureens' point there, actually, funnily enough, and it's a lot of what Lewis has obviously outlined very eloquently during the course of this. So you're absolutely spot on, Maureen. So essentially, obviously, as Lewis said, that we're the co-founders of VISR. My background is in manufacturing. My mother's family was very much in horticulture, and we have got to a certain point when we look at our economy of where Lewis started, but I'll say it more bluntly, there is a bit of but what about us going on at the moment. There's a huge swathes of people who are being trained, or industries that are trying to attract younger people in with technology sort of enabled youth who don't want to go into these businesses because they're being undersold to them in terms of they're not tech, that they're more traditional sectors, and it's really important for our future workforce and career opportunities for all of the predominantly young people in our region to feel included in this much bigger dialogue that's going on with regards to technology and what technology can do. And as Lewis said, parts of us as information workers, which we all are, have been really well catered for. So we're spoilt, but there's a huge amount of people that aren't at all. I mean, they sort of get the scraps from the table. They have to make do with what they get. And I think the really exciting thing about this is that we're actually being truly inclusive. We're saying that there's space for you now. We're working this out, and actually we can include you into what the future looks like in terms of how you work and how technology will enable you to work better. I think that one of the things that we've got in our particular region, why the IoT is great, but is challenging at the same time, is, so just speaking now as an older ambassador for the Humber region, is, you know, we're very blessed in our part of the country to have Lewis, who's originally not from here, but to go to university here and find his home here. And we've got one of the strongest voices in the whole country in Lewis, who's actually talking about this technology and what it can do. And we find that many times, present company not included, it's very hard to get this message over. This level of expertise that Lewis has brought to our part of the country is here. We've got a massive opportunity, both from educational, for every element of education, and actually remapping how we teach, creating modules, looking at how we engage with young people, how we attract people in traditional industries. All of this could happen in our part of the country if we embrace it properly. But we've actually got to once be confident in the people that we've got in our part of the country and believe that they're as good as anyone in the world as Lewis is. So I think that's a really important thing as well, Maureen, that we've got to address. The answers aren't always out there, they can be here.
I think it's, yeah, I mean, that's, you know, going back to, you know, my search for university to go to, you know, it was, we actually got a really long decorated legacy of being really good at this in this part of the country, just nobody really knows. And that's, you know, I learned engineering from Warren in this call. You know, we've always been good at this here, and typically I'm now from Yorkshire. I've lived here long enough. I can say I'm from Yorkshire. You know, being from Yorkshire, because I associate myself with this, you know, the concept of, I know what it's like to be downtrodden by society. So Hull was obviously my home. You know, for me, we are no good at telling people that we're great at this. We're too humble and we're too tough and just getting on with it. You know, we never have sort of the ambition to highlight that we are really, really good at this kind of thing. And we are. This is probably one of the best and most densely populated places in the country for this kind of work. And actually, interestingly, Yorkshire in general as a band that goes across the country is the hub for AI and spatial computing innovation. Most of the businesses receiving most of the investment in the fields happening in Yorkshire. And, you know, okay, a lot of that happens in Leeds and Newcastle as well. But, you know, the M62 corridor and the band that we're in is where this revolution is happening globally, which is really interesting. And, you know, something that we should be part of from an educational perspective, which is why we were so excited to join the IoT, because we can bring this voice into teaching people in the future as well as thinking about the present and building companies and that kind of thing.
Actually, just on a very separate note, just to share how crazy these things are going, obviously I get a lot of information feeds that are coming on in the virtual world, and just to show for opportunities going forward, it's very off the mark of what Lewis is saying, that there is a virtual Gucci handbag. So it's virtual, it's not real. It's just sold online now for $4,000, which is actually more expensive than a real one. So this is actually infiltrating all parts of our lives in the future to go. So I don't know why anyone personally would pay $4,115 for a virtual bag, but apparently there you go.
But isn't the problem with that puts off the people who are actually the ones who are in the real world and aren't the information workers? They think, well, they're all stupid, these people.
Yeah.
And that doesn't help us, does it, to actually sort of integrate properly and to really change things, because you can't change things if people don't want to change.
No, oh well, exactly that, and it's about, it has to be led by proper change management strategy and understanding change and how you bring technology into business. You can't, it just put a HoloLens on someone's desk and say have fun with that, and the project will fail. It needs to be wrapped in more strategy than that. The same, we'll be doing that with VR teaching. That will be a really fun bit of change management to do, and introduce this as a tool and make sure that people who use that kind of kit are ready to author those kind of experiences themselves, like they would a PowerPoint, and it's not beyond them. This stuff's not difficult. We've just got to get that messaging right. And the same thing will happen for, frontline work managers and OIMs and offshore installations and all that kind of thing, that they will be the creators. And, that'll be a really interesting future to live in, and one that we'll make happen here.
I think as well, Maureen, just on that one, and I mean, obviously that was joking aside, Lewis and I have actually, obviously before VISR, worked together on big video game events that we used to hold in Hull for about 6,500 people. But obviously with our combined backgrounds of his technology and obviously mine process and manufacturing is that on a very serious level, we have always had, what tends to happen in an organisation with technology, it has quite a top-down approach. People at the top will look at it and say, this is great, we've got to push it down into the organisation because it'll have benefit. If you look particularly on the Centrica elements that Lewis was talking about, so a couple of weekends ago, he spent a full weekend offshore on an oil rig. We've had
no, I didn't. It's still confidential.
No, sorry, obviously he didn't do that, everyone.
A couple of weeks ago, I was on holiday. Yeah.
But we've had a bottom-up approach, and that bottom approach is obviously, because I mean that's my day-to-day understanding of it is that real people working with their hands or machinery or in field need to be included in this conversation. It can't just be technologies coming down, because there's an inherent fear of that by the existing workforce, because technology and Industry 3.0 automation was there to replace people. Industry 4.0 is quite different. It's how do we enhance humans and data technology together to make to improve process. So we very much engage very much with the real workers and what they do and what they think and how easy they think this is going to be and what challenges that they see coming with it. And I think having that narrative and their input into it is probably the most valuable thing that we've got, isn't it, Lewis? Because that's actually how real people work with it every day, not how boards who sign off checks think about it.
It's nice because they do actually, once you get in front of the frontline workers, though, they think it's cool. But we've had a lot of exposure, particularly with Centrica, that you would think that a sort of 50-year-old organisation that gets gas out of the sea would have a pretty clear-cut way that they were going to do it that way, and that's going to be it. But actually, they've been very receptive to the role of new technology from the bottom up, if you like. So it's been much more difficult to convince the strategic leadership than it has the people working on the front line, because you can give the person on the front line the headset and say, see that thing that's crap, try it like this. And, this is fantastic. I'm now not wasting my time. And so it's really interesting, and that kind of brings us. I'm conscious we'll run out of time soon, but that brings us very round back onto the original point. That's why this starts with education. This starts with technological expectation for people coming out of training, going into that kind of organisation, saying, "Where's my AR workflow? Why don't we do this?" And actually, that's what causes the sort of inception of the idea within the organisations is planting the seed early. We, as Lindsay said, we worked together on some video games initiatives years ago to raise the need for colleges to push people into computer science roles. All of our senior engineers in our business are people who were on those programs. So we have personally reaped the rewards of what we sowed back then. It works, and now we've all got to do it together for spatial computing and the world of work. But those patterns repeatedly work as long as people want to invest in them.
I think as well, just on a final note, Maureen, just on that real work with real people, the other thing as well is that we see, which is a big opportunity again for all education, is that many of these traditional roles and jobs, we've skipped a generation. So that frontline workforce as it currently stands now, they're probably more my age than Lewis is, worked hard and maybe looking for retirement, and they see the problems coming because there is there is an immediate shortage in that 25 years where people were probably pushed away from some of this types of work that we're looking at into more information processing work. And the big requirements now for the workforce is that how do we attract the future generations into whether it's agriculture, farming, manufacturing, energy, and the older workforce knows that, and they know that something has to be done. So they're quite keen on how we can get information off them, extract it out of their heads, and get it into the heads of younger people, and are keen to know how that can be done.
I think that's a really important point. You know, the average age of farmers in this country is now getting on for 60, I think, and yeah, that is just crazy. We've got a real risk there, and so
massive risk.
We need to not lose that knowledge, but also we need to make the industry more attractive to younger people. And you know, okay, you still got some people who just want to spend all their time in a field with cows or whatever, but actually I think young people have higher expectations these days, and they want a more varied, more interesting and a more relevant role. And so, you know, that's, I think, where this comes in to help us to do that.
And I think, yeah, it's about
it in sort of an efficient way as well, if you don't mind me there. Obviously, as you say, there's this, you know, it's interesting what you say about the average age of farmers, you know, being about 60. You know, we're going to meet a point, aren't we? Or we're meeting a point where we are going to realistically potentially run out of people. So, you know, these technologies as well that we're talking about, they're not only good for, you know, just training people up in new ways of working. They're actually proven to be more engaging and retentive for people whilst they're, you know, going through training and learning. I think there was a study which I'll find and I can post, but I think VR training in general improves retention of information by about 70%. So you could even half the actual amount of time that it takes to actually train people up in these vocational, you know, in these skills as well, and you know, just increase the churn of people that you have coming in and out, and you know, trying to attract people onto these courses. It could be very interesting.
And it goes back to that first point of Lewis, is that it's about time that we're inclusive with these people. They've been in some respects left behind. So it's nice to see that technology actually is recognizing this and doing something about it.
Okay. Any more questions from the floor?
I just like to say I think that's been very helpful. I found it very interesting. So I didn't know a lot about your organisation apart from I knew we were working with you, but I'm very interested to learn more. So you might see me at your demonstration centre one day.
Do so, yeah. I mean, if I have a closing
We'd
note,
love
it's,
to.
you know, that Amy has helped us spend a lot of money setting all this up. It's there for you as members to use. So we're not going to be charging you for it. We want you to come and see it. We want you to start a narrative with us about how your learners engage with this technology. Maybe even start a narrative about how one day you'll build centres like this of your own. And you know, that for us would be the core kind of set of next steps we'd love to explore with you all, because it's about, as Lindsay said, this being inclusive across the group. That's why the centre's open. It's like an open source concept, but it's real. And you can take the design away and have your own if you want. And you know, we would love to, and you know, we're coming out of lockdown. We've got a lot of toys here that they're there for people to play with and get value out of. And so please, you know, Alex has got everybody's email. Just email us and book in some time. Maybe come down as a small delegation. We'll bring you class if you want to do a day of stuff. We can help you organise activities for them to do, and you know, get value out of this, because ultimately this is what it's for. And it's been really nice speaking to everyone. Thanks for everyone's time today as well.
Thank you,
I
and I'm
just
sure
want to
we'll
say-
be visiting.
I want to say thank you, Lewis. That was really interesting, and I think really useful. And I say I've been to the facility and I've seen it. It's really good, and I think, you know, there's a resource there for the IoT, and it's really important that, you know, partners start now to make use of that, you know, and build that relationship with VISR as well, you know, and start to look at this technology. Funding, for example, is being aimed at IoTs now for around sort of developing modular courses. You know, there's a fantastic opportunity to develop some modular courses around, you know, this subject and this technology, you know, and start building it into some of the curriculum and some of the ways of teaching and learning as well. So I think it's a really good opportunity for the IoT, and you know, one I want to see partners make the best use of.
Thanks, everybody.
Thank you.
Thank you.
Thank you.
Thanks
Bye.
so much,
Thanks,
everyone.
Lou.
Good to see you, and
Thanks,
thanks,
Lewis.
Lewis. Okay, bye.
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 Thank you.